Hello, my name is Shravani Abhijit Kulkarni, and today I'll be presenting on the topic Building Machine Learning Models in Scikit-learn. In this presentation, I'll explain why Scikit-learn is important, what it offers, how it works, and its limitations. And finally, I'll summarize its role in the field of machine learning. Now let's see why scikit-learn is an important library. So machine learning is very important technology nowadays. From Netflix recommending the shows to banks detecting the fraud, ML models are everywhere. But here's a catch. Building these ML models from scratch is very difficult. This is where scikit-learn comes into the picture. Scikit-learn is a Python library that makes ML model building easier, convenient, and more efficient. Think of it like this. Suppose you are baking a cake. Following the normal recipe, you would first add the flour, then eggs, then sugar, and then bake it carefully. But Scikit-learn is a ready-made cake mix. It provides you with the basic simple recipe. You need to add your own data to get the desired result. So Scikit-learn is an efficient library to test and deploy ML models quickly. So now let's talk about what Scikit-learn is. So Scikit-learn is an open source Python library which is built about all other machine learning libraries like NumPy, Pandas, and Matplotlib. It provides wide range of ML algorithms such as classification, which is used for categorizing the values and predicting the different categories. Then configuration, which is used for predicting the continuous values. Then clustering, which is used to group similar type of data values, and dimensionality reduction, which is simplifying the large data sets. The general workflow of building ML models with scikit-learn includes: first, you need to load your dataset, then pre-process the data, which is handling the null values and scaling your features. Then you need to split your dataset into train and test sets. Then you need to choose the right model to train your dataset, then predict output, and then evaluate the performance based on the accuracy and precision of your model. Then let's take an example where scikit-learn can be used. It can be used to predict whether a student passes or fails in an exam based on how many hours he or she studies and how is their attendance. Now let's see how scikit-learn works internally. At the core, every scikit-learn model follows a standard API. It includes functions like fit, which is used to train the model on the data, then predict, which is used to make predictions, then score function, which evaluates the performance based on the accuracy and precision the model shows. The architecture is modular and consistent. For example, pre-processing classes like standard scaler for feature scaling, model classes like logistic regression and decision tree classifier, evaluation functions like accuracy score or confusion matrix. The working example of scikit-learn is as shown in the code. Here, we have used the iris dataset and uploaded it using the load iris function. Then we have split the data into train and test sets using the function train test split. Then we have trained the model using the function model.fit in which we have passed the parameters xtrain and ytrain. Then we have made the model to predict the values based on using the function model.predict, and we have passed the parameter of xtest. Then lastly, we have checked the accuracy of the model using parameters like ytest and ypredict. So, for example, if we take that our accuracy is 0.96, which is 96%, that shows that our model works well on the iris dataset. Now let's see the challenges and limitations. Although scikit-learn is very powerful, it also has some limitations. First, it is not suitable for deep learning. In deep learning, we can use TensorFlow and PyTorch, which are better options than the scikit-learn. Second is that it struggles with large dataset than the other ML models. Third one is that most of its operations are on the CPU rather than the GPU. So processing speed, that is training speed, can be slower. Then it requires manual preprocessing and hyperparameter tuning. If we take example, if we are trying to train a CNN for image recognitions, for example, we are trying to classify the dog and cat images, it is not efficient to use scikit-learn. We can use TensorFlow instead, which is a better option. To conclude, Scikit-learn is one of the most popular and user-friendly libraries for building machine learning models. It has general workflow like load, preprocess, split, train, predict, and evaluate. It is best for small to medium datasets and for quick experiments. It has some limitations like it is not ideal for deep learning and also it is not ideal for very large data set, but still it is important and can be helpful for some tasks like iris classification, house price predictions, and spam detection. In future, while deep learning frameworks dominate the large scale AI, scikit-learn would still be useful for beginners, researchers, and for quick ML experiments. Thank you for listening.